In the next section, the first thing I want to point out is that these are still right triangles. So SOHCAHTOA still applies here. The only difference, though, is we're not solving for a side in any of these problems. We're asked to find an angle. So remember, the normal definitions of sine, cosine, and tangent, they give us ratios of sides. In these problems, we already have the ratios of sides. We're looking for the angle. So we're going to be using the inverse trig functions to help us do that. Remember, the inverse trig functions tell us what the angles are. So let's go ahead and get started on number 4. So we're asked to find this angle. It's labeled theta. And we are given these two sides, 4 and 14. So I do notice that 4 is directly opposite the angle theta. And I also notice that the other side, 14, it's the hypotenuse since it's across from the right angle. So opposite and hypotenuse is what we've got in this problem. So theta, the angle that I'm looking for, it's going to be actually equal to the inverse sine. Since it's opposite and hypotenuse, it's going to be equal to the inverse sine of 4 over 14. Opposite over hypotenuse, since this is a sine problem. So let's see what this angle is. So I have to press second first to bring up the inverse function. So second and sine brings up the inverse sine for me. I'm going to do 4 over 14. So this angle is about 16.6 degrees. So theta equals 16.6 degrees. All right, moving on. Number 5, we're asked to figure out this angle theta. And it looks like we are given the side opposite theta as well as the side adjacent to it. We are not given the hypotenuse in this problem. Remember, the hypotenuse would be this long side here on the bottom, which we do not have in this particular one. So we've got opposite and adjacent. So I just realized I can't spell TOA apparently. So opposite and adjacent, that means we are working with tangent in this problem. So I'm going to have to, since I'm looking for the angle though, I will have to make use of the inverse tangent to do that. I've already got the ratio of sides here. So if I plug that into the inverse tangent function, it'll tell me what the angle has to be. So opposite goes on top, adjacent goes on bottom. So 12.3 over 6. So let's figure out what this angle needs to be. So press second and tangent inverse. So I'm going to put 12.3 on top, 6 on bottom. Close parentheses. So 63.99. If I'm rounding to the nearest tenth, that would make this angle 64.0. So 64.0 degrees is my answer here. And last one in this section, number 6. So I'm looking for this angle right here. So let's figure out what combination of sides we've got. Does it look like we have the hypotenuse since the side labeled 10 is across from the right angle? And looks like we've also got the side adjacent to theta. So adjacent and hypotenuse. So that means this is a cosine problem. But since I need to know the angle, I already know the two sides, I need to know the angle, I need to use the inverse cosine. So I'm going to plug the ratio adjacent over hypotenuse into the inverse cosine function. So adjacent in this case is 8, the hypotenuse is 10. So the inverse cosine of 8 over 10 will tell me what that angle has to be. 8 over 10. So it looks like we've got 36.9 degrees if I'm rounding to the nearest tenth.